So, hello again. So, good morning again, and it's me again, Federico Tigbak. So, for now, we will read I create a summary chapter tutorial of chapter 5 in PowerPoint. So, let's go for gain another knowledge. So, Chapter 5 Summary Tutorial. So, first, the Chapter 5 began with a look at IP addressing basics. This include an overview of the binary decimal conversion process. It continued with an introduction to classful IP addressing, where we outline how the 5 classes of addresses are identified and the number of hosts that each addresses range supports. The number of available class A, B, and C networks were also calculated. An overview of IP addressing rules outline the 8 key rules with respect to host addressing, such as the rule that mandates the host portion of an address cannot be set to all binaries OS 0s or all binary 1s. The concept and the purpose of a subnet mask was introduced, including its relationship to IP addresses, in defining the split between the network and host portion of an address. Default subnet mask values, when they are used, were also examined. A look at the private IP addressing provided insight into the flexibility that using these addresses provides to organizations, as well as their purpose in helping to avoid the exhaustion of the current IPv4 address space. The special subnet masks associated with the 3 private ranges were also examined, along the ranges of addresses that each supports. So, an overview of subnetting provided insight into reasons for deciding to subnet A network. It continued by determining the subnet and host per subnet requirements that should be determined when characterizing a network. So, the process for determining custom subnet mask was covered in detail. So, including an overview of how bits are stolen from the host portion of the mask in order to allow subnets to be defined within the address space. So, it will be calculating the number of subnets and hosts per subnets available based on a given mask value was also looked at. Next, we look at defining the ranges of addresses that were valid on a given subnet, including the process of determining the beginning at the end and the end of a given range. So, it determining the beginning and the end of a given range. This included an overview of ranges associated with class A, B, and C addresses in common subnetting situation. A subnetting challenge question was used to show how even questions that appear difficult are easy to solve if the rules outlined are followed. The subnetting shortcut provides an overview of a quick and easy method of determining both custom subnet masks and their associated address ranges. It can be used as a simple reference for exam purposes. The process of determining whether hosts are local or remote to one another look at next. I learned that the ending process provides a way to not only determine whether the hosts are local or remote, by also to find a network ID associated with a given IP address. A look at classless addressing provide insight into how addresses are now more commonly looked at in this manner rather than by class. An overview of CIDR provided insight to supernetting address aggregation and slash notation. So the MAC address is the unique network adapter serial number distinguishing that network card from all others on the network. The MAC address is made up of two parts, so the OUI and the vendor assign the serial number. Half duplex Ethernet uses CSMA or CD as the LAN access method. When an Ethernet device wants to gain access to the network, it checks to see whether the network is quiet. If the network is not quiet, the device waits a random amount of time before retrying. If the network is quiet and the two devices access the line at exactly the same time their signals collide. When the collision is detected, they both back off and each waits a random amount of time before retrying. For the repeaters generate signals in cable line and are used in both local and wide area networking environments to extend the distance a signal can reach. Ethernet hubs are multi-port repeaters because signals that is received by the hub is repeated out all hub ports and is received by any devices connected to the hub. Ethernet bridges are essentially multi-port hubs. Instead of repeating the incoming signal out all ports, however, the bridge maps the MAC address to a port. This map keeps of the MAC addresses of each node that reside on each network segment and allow allows only necessary traffic to pass through the little bridge to the bridge, such as traffic destined for a segment other than the source. If the frame source and the destination network segments are the same and the frame is filtered, if the segment is different, the frame is forwarded the bridge to the appropriate segment. So the LAN switch is a network device that cross-connects substations or LAN segments. Network switches replace shared media, have increasing network bandwidth. Each of the switch can give full bandwidth to a single server or client station, or each can be connected to a hub with several stations. The switch also forwards a frame all ports if the destination MAC address is unknown. Routers are basically computers with two or more NICs supporting one or more network protocols such as the Internet Protocol or IP. So that's all for now. This is the chapter summary tutorial of the chapter 5, so please don't forget to subscribe.